These three examples, 10D, 12B, and 14B, are all practicing the same thing. How to find the second derivative when given the first derivative. Keep in mind in every case that y is a function of x. So we'll need to keep that in mind as we do derivatives because it'll require the chain rule. Alright, so the second derivative will be the derivative of the first derivative. There's a derivative of the first factor times the second factor. Now we're going to multiply the first factor times the derivative of the second factor. And remember, we're taking the derivative with respect to x. That's why we'll need the chain rule, because y is a function of x. So the derivative of 1 is 0, and the derivative of negative y is negative 1, but times dy dx, which we know, because it was given to us, is that expression. So we can factor out the common factor of x, and that leaves us with 2 times 1 minus y minus x cubed times 1 minus y. And if we factor out that common factor of 1 minus y, then we're left with 2 minus x cubed. This will be our final answer for 10D. All right, let's try 12B. All right, they gave us the first derivative and asked for the second derivative, which would be the derivative with respect to x of the first derivative, which was xy. Keep in mind that y is a function of x, so we'll need to use the chain rule. First, we have to use the product rule. The derivative of this product will be the derivative of the first term times y plus the derivative of the second term times x. Here we go. So 1 times y plus the derivative of y, which is 1 times y prime times the first factor of x. And y prime is xy, so we'll place xy in for y prime. So there's a second derivative. And in 12b, we're supposed to determine whether the approximation in part A is less than or greater than f of 1.2. And this is our approximation of f at x equals 1.2. How is that versus the actual value of f at 1.2? Well, now we know what the second derivative is. And that's going to be the y value, which is approximately 1.221, plus x squared y. And 1.2 squared is 1.44. We know 12 squared is 144. And then times the y value. So this is clearly positive. And since this is positive, 1.221 is less than the actual value for f at x equals 1.2. Because if the second derivative is bigger than 0, it's concave up like this yellow curve. And if we're doing a linearization, the entire line will be underneath, and therefore our estimate will be a little bit underneath or smaller than the actual value. All right, now let's take a quick look at number 14b. Here we go again. We're given the first derivative and then asked for the second. So the second derivative will be the derivative with respect to x of the first derivative. Keep in mind that y is a function of x. You can leave it like this and use the quotient rule. I'm going to rewrite it like this and use the product rule. Here we go. It's equal to derivative of x is 1 times y to the negative 2 plus x times the derivative of y to the negative 2. And that is negative 2 times y to the negative third times the derivative of the function y, which is x over y squared. All right, so we can simplify and get our final answer, which you can write either way here. 1 over y squared minus 2x squared over y to the fifth, or if you multiply this by y to the third over y to the third, then we have y to the third over y to the fifth. Common denominators, we can write it this way. That's the way the book did it, but I probably would have left it like that. That's it. I hope this helps with that type of question.